Hi, everybody. This is Mr. Colley, right before your test, getting all ready for you to give you the most current, up-to-date, amazing lecture on chemistry for Big Idea 4. I've got a big idea forming in my head. So now let's start. Physical changes do not change the properties or identities of elements. Okay, so most common in AP chemistry are phase changes. So solid to liquid is called melting. Liquid to solid is called freezing. Liquid to gas is called boiling. What I forgot to mention on here is gas to solid is sublimation, and solid to gas is also called sublimation. I should write the whole word out. This is also sometimes called deposition, like a deposit. Okay, and there are also phase changes. Okay, notice the number of particles doesn't change. And then I put it right there. Forming a solution is also a physical change, so that means dissolving. Okay, cutting, bending, grinding is a physical change. All right, chemical changes. So chemical change means you have to have new thing form. New, I'm going to call it a substance. Same thing, but still. Substance. Got to have something new. New means new property, something new. Signs of chemical change. Precipitate. Haven't seen a lot yet. That's where a solid forms from two solutions. Color change. If you burn your toast, for example, color change. Light or sound. Hey, burning's a pretty good one like that. Gas forms, digestion. Excuse me. Better out than in, I always say. And a new substance form is always, that's the best one. If you know there's something new, wow, not precipitate, new substance forms. That's it. Common patterns in chemical reactions. So you don't need to memorize that this is synthesis, decomposition, or single replacement, but the patterns you should be pretty good with. So A plus B yields AB. Hey, that makes sense. Na plus Cl2 makes NaCl. We have to talk about balancing charges. Balance charges. Okay, so sodium is +1, chlorine is -1. That's why if I put the 2 there, NaCl2 would be +1 -2, no bueno. Okay. Decomposition, one thing falls apart into two. You don't need to be able to predict exactly how they're going to fall apart, but they'll be different on things that it makes up. So like this is a compound and an element. It's often elements. And Excel, often is our typical AP chemistry. Often is about 40% of the time, right? Single replacement, same thing where you've got two things. C tries to come and replace one of them, so C can replace B, and C can replace A. But the difference is C matches type of substance. What? So metal and metal switch, or non-metal and non-metal switch. So, for example, if you play fantasy football and your quarterback gets hurt, you put in your backup stinks. So you go to the waiver wire and you try and find a new quarterback. You don't get your quarterback hurt and try and find yourself a new kicker. All right. Double replacement is often called metathesis. Sometimes it's acid-base, but not always. And sometimes, not always, but usually, it's precipitation. Okay. So precipitation, remember, is a solid. We need to have solubility rules. Combustion means we're going to add oxygen to each part. So we're going to make our most common oxide. So CHHY with or without O. So I'm looking right here. So maybe there's an O, maybe there's not. I'm going to make the most common oxide of carbon, CO2, most common oxide of hydrogen, H2O. Now, if you are low on O2, so this happens, say you're up in the upper atmosphere, there's not a lot of oxygen. If you're low on O2, you get CO plus O2. Carbon monoxide is the stuff we have little detectors for that people come in and look in our room. Hey, where is this? It's a poisonous gas, and it happens if you don't have very good ventilation and don't mix your air enough. Then you get low oxygen, which then would give you the carbon monoxide instead of the carbon dioxide. Carbon dioxide is virtually harmless. A metal plus oxygen gives you the metal oxide, and you figure this out from the charges. And then just an example of propane burning. Magnesium, notice magnesium is +2, oxygen is -2. I want to say this, never show charges on ionic compounds. So you use them to check, but once I see them, I'm like, these have got to go. So they go. Hi, Eva. Redox or not. Redox reactions have charges, oxidation numbers that change. Non-redox reactions have charges that stay constant, typically precipitation. Ooh, look, an empty page. I can fix that, I think. There we go. And we'll stop right there. A nice 5-minute deal. Toodles.